Hey guys, so today we're going to go over one of the other techniques to finding a limit. So a couple of algebraic methods is to factor and divide out so that you can apply direct substitution. Another method is you can actually just try to apply direct substitution. So I want you to notice here if I apply direct substitution, so if I replace the x with 0, I'll get a 0 denominator, which doesn't mean that there isn't a limit. It just means find another way first and just check. So the limit may not exist, but go through a couple of the algebra methods, such as factoring to divide out, which I've shown you in the other video. Another one is to rationalize. So instead of rationalizing the denominator as we've done in algebra, here I'm going to rationalize the numerator. So what I'm going to do is rationalize the numerator, which means I'm going to multiply this numerator by its conjugate. So I'm just going to make a note of that. Rationalizing the numerator. So I'm going to multiply it by its conjugate, which means it's going to be the same exact term. So the first term is the square root of x plus 1. Notice that the expression is still plus. And the second term is 1. So between these two terms is a minus sign. The conjugate of that is the opposite operation, which is a plus sign. So conjugates have the same exact terms, just opposite operation in between. So if this was a plus, this would be minus. If this was a minus, this would be plus. So whatever you do to the numerator, same rules still apply. Keep the fraction balanced, do the same to the denominator. And then from here, remember, we multiply fractions going straight across. So sidebar, I'm going to multiply the numerator first. So if I take the square root of x plus 1 minus 1 times the square root of x plus 1 plus 1, you could do FOIL. But there is a trick to multiplying conjugates. You could do FOIL, but what happens when you do FOIL is outer and inner will always add up to be 0. So the shortcut or trick to multiplying conjugates is you could also do what's just called Florida, meaning first and last. Now, if you do FOIL, you'll still get the same answer. It's just, the outer and inner will add up to be 0. So I'm going to show you just first and last. So square root of x plus 1 times the square root of x plus 1 is just going to be x plus 1. So just a little trick here. If I multiply anything that's the same square root of 3 times square root of 3 is just the square root of 9, which is just 3. So same thing with square root of x plus 1 times square root of x plus 1. It would just give me the square root of x plus 1 squared. So squares and square roots get rid of each other, leaving you with just x plus 1. All right, and then last, negative 1 times positive 1 is negative 1. So combining like terms, x plus 1 minus 1 will just give me x. So this numerator is just going to be x. I'm going to bring down the limit as x approaches 0. And for the denominator, I'm not actually going to distribute. I'm just going to bring them both down. And there is a reason why I'm doing that. So as I write this down, remember when I showed you factoring to divide out. If you can factor it out, you can divide it out. So keep that in mind. I kept this in parentheses because it's factored out. It's a GCF, it's factored out. If you can factor it out, you can divide it out. So notice there's nothing up here, so there's nothing else to factor out, which means the x and the x can divide out. Now, this does not magically move up to the numerator, so keep that in mind. X divided by x. Think of it as 2 divided by 2, 3 divided by 3, 4 divided by 4. When you divide the same things, you will get 1. So this becomes the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Once you rationalize the numerator and you divide out, you're going to check direct substitution. So I'm going to replace all the x's with 0, giving me 1 over the square root of 0 plus 1 plus 1. And square root, 0 plus 1 is 1. The square root of 1 is 1. Everything else I'm just bringing down. And that would give me 1 over 2. So that would be the limit. All right, guys, hope this helps.